All right, so I'm just going to do a new and don't need to save. All right, so for our assignment 9, we have this piece, and notice that I've given you an x_t and a dxf. I'll probably do a, if you want to draw it or need to draw it, don't have access to this, I'll do that later on. It's going to be the same type of thing that we did on the first one, though, since I got myself into a little bit of trouble with the trying to go point to point. So drawing the rectangle, setting up the physical boundary, doing the offsets. One of the things I was looking through last night that I didn't realize was the line parallel. And I've seen it before, and it was one of those, hey, what does that do? And line parallel is basically the exact same thing as offset. It's just right next to your line commands. So we'll look at that one. But if you use the x_t, that's going to be a solid. And if you use the dxf, that's going to be another wireframe. So what I was mentioning is the line parallel, create a line parallel to an existing line, which if we come all the way over here to offset, has the exact same interface as offset. So I'm not really understanding the thinking there, but it was interesting to have those two options, and then line perpendicular and line closest. A lot of times I don't, as you may have gathered, I'm going to draw in SolidWorks. I'm going to draw in a program that I am way faster in, and I just want to be able to make those quick modifications without going too crazy with it. So if we go to import or open, and I want to go to the computer and browse to the documents. All right, so it's not showing me anything until I go over. So if I tell it the DXF DWG, that's going to give me my wireframe. And we'll just pick the layout, for whatever reason, when SolidWorks outputs those, it always does the layout 1, layout 2. So there's your geometry. That's enough to start programming from. As you have access and you do more with solids, we're kind of at that point. I like the wireframe. The profile, especially in lathe, is a lot easier to kind of visualize, manage. The mill, though, I'm all about solids. That being able to rotate and see those geometries, pick up those other planes, I'll take a solid any day over just plain wireframe or the 2D drawing. All right, so if I were to go back and let's do an open and have it go back to the documents, and we look for that parasolid x_t. So text, binary, and that one's one I don't recognize. And we tell it to open. Now we're going to have the solids. So with the solid, we actually need this solids tab because it's going to have the body, the geometry, and if we make modifications, say there was something we came back and we wanted to add another slot, we could do that to the solid, and it would show up as part of the list for the creation of that geometry and would keep track of your history. All right, so visually, I think it's kind of nice to be able to see and have the shading. The one thing to watch out for that we learned, not picking on anybody, was if you manage to bring this in and
some features
and shift it just a little bit. So if I'm going to do this on the purpose, we translate this back, and I grab the entire body, and in the selection, let's see, we're going to be going in Z. So I'm going to shift this back 250. Okay. Oh, I copied it. Notice, probably should have made that a different level. But notice that the profile that it's going to pick up with that offset is going to be a little bit smaller on that diameter and have it's going to follow that edge just a little bit different than if we're on the other geometry. So from the front, it's going to look okay. The toolpaths are going to be okay, except as we start to make those cuts. And let's just do a Control Z. It's gonna mess me up a little bit. So the 0.25, and we'll do a move this time. So if I look at this from the top, all right, once I figure out which way I need to look at it, okay, so 7, we went top. Oh, all right, how about the end? I've been through all of them now, it's got to be one of them. All right, so we've got that shift. Oh, I got it shifted in X and Z as well. Oh no, there it is. It went that way. All right, so where this line passes through, it could miss this geometry altogether. You wouldn't even see that hanging out in space. It might not pick it up. All right, so that's one of the things with the solid. If you're on the wireframe, it inserts it on the top plane. We can double check. But with the depending on what program generated what they picked as the origin for this translated file, this could come in any orientation, and you've got to be prepared, like with the dynamic, to do those rotates, get it into position so it's laying along right now the x-axis, so that when we go into the lathe and it picks up our DZ, that the Z is pointed in the right direction, the D is pointed in the right direction, and you're getting the desired result. All right, so in selection, and finds my center. And am I copying? No, I'm moving it. I think I'm moving the triad. There we go. So let's play that game again. We'll go through all of them just because. All right, so it looks pretty well centered. But point is that it's going to take that profile at whatever cross section it finds, and especially with the solids. So, all right. So with the DXF, it comes in with the wireframe. It's just as if we'd drawn it. The thing with the DXF is it scaled. If it came in off of a drawing file, you would need to measure some geometry and check that it's not a 1:2 or a 2:1, something like that, because usually you program the whole thing, and what always happened to me was, oh, I took my my 1/2-inch drill, and the thing was this little tiny speck in this huge bore, or it just wiped out the whole part when I drilled with the 1/2-inch drill, or 1/4 or something along those lines. Something came in that was actually give you a visual reference to your scale, and all of a sudden it's all over the place. All right, so make it a habit of measuring a couple of things. And so even on the solid, I believe I'm going to be able to hit F4. Oh, entity to analyze. We pick that edge, and we are at 1 inch, which sounds right, I hope. Let's go back and check.
Bless you. Thank you.
All right, so 1 inch on that diameter gives me, good visual with it. All right, so we will jump over to machine. Also with the solids, not really doing a lot in here, but if for some reason I wanted to take the DXF and revolve it, when the solids are turned on, I could turn that into a solid, and would stay consistent with our process if we were going to say we're just going to work in solids. So, all right, so I'm going to pick up the default lathe. I will check that the items that I set, number 1, assign tools and numbers, and let's go ahead and put it in some aluminum. And we'll pick up the lathe library, aluminum 6061 is fine. And then the stock setup, we're going to go to the properties. All right, and then this is what I was saying in the other video too, as well as the margins. I know that this is OD of 1.4. And so typically I would say, well, I'm going to use 1.5 inch stock, so I just go ahead and put in 1.5 stock. Right, but that doesn't really keep track or give me the information. 4 inches should be okay on the length, but this was actually a 3-inch length of stock, or a 3-inch length on the part. So if I wanted to keep that a little bit closer, and what one is staying, oh, and actually I would say that there's looks like there's a problem with my model. So I went 1.4 all the way down. I believe it was, or 1.3 all the way down. I think it was 1.4 at the outside. So nice time to figure that out. We could go back with a Boolean operation and add that in. I'll save that one for later as well. We'll see if we can update and what happens when we make those adjustments on the fly. Since I haven't prepared that one, we'll save it for later. But that should be the type of things that jump out at you as, wow, I have a 1.4 diameter. Why isn't my stock the same size as my material or the same size as my part? All right, so if I go over to the margins, and the OD margin, we're going to set it 50 thousandths difference. The first time I checked this, same thing. I said, well, is this a radial or diametral? You know, is it adding on to the diameter or is it adding on to the radial? So would set it and then see how much bigger it got, and it was quite a bit bigger. So we're actually adding that radially. So 50 thousandths is enough. The right margin, just enough to clean up the end face, so 30 thousandths. And the left margin, if I give it 2 inches, that's way more material than I need to hold on to. Let's see if I can zoom that out a little bit. Okay, it's not going to let me zoom, but it's over here somewhere. All right, and then the properties. Now, if we're going to use the margins, the other one that comes in handy is then from stock. And from stock is going to look at that stock diameter, which it gives me as 1.5. We went 1.4 on the size, and then somewhere, see, the grip length, we want to hold on by at least an inch. So that's going to show the jaws in relation to the part and that I have enough clearance. So we're going to follow the standard lathe rules of the further I stick this out, the less rigidity I have, the more chatter, the harder it's going to be to maintain that surface finish. So at some point, this is for reference. It really comes down to what I do on the setup sheet, how my setup and my operator are loading this part, and performing those touch-offs. So we still have to manage that information. All right. So again, these are for reference. This is not anything that's going to say at the machine, really that the machine has to be this way. It's visual for how we're going to program and set our clearances. All right, so I'm going to load up tools, but I want to pick up a button tool because I've looked at the dynamic a couple times now. So for the rough, we're going to add just our 5/16, 3/8, was that a 55 or an 80? Okay, so the 80 degree, that's going to be a good rigid tool for roughing out the material. I really don't see that I'm going to be getting into these areas with the 35 degree. If I cut this back, if I did 45 and 45, I could probably get that 35 degree to go in there and clean up a little bit. Depends on the stock geometry. So let's go right to a grooving tool. Center, left, left, right, doesn't really matter. I would say I kind of tend towards the right side just because we're coming up against that spinning chuck, and I guess that's going to be the one that typically I'm gonna pick for. So I picked an 1/8 inch. We could go up to whatever this width is, but at some point we're going to have trouble calculating the tangency. So most shops are going to have that 1/8 inch insert cutters, so we can go with it. And if I can locate, so there's our boring bars. I don't have anything internal, and we haven't really focused on anything internal, so there we go. So a 375 button and cut off, and that one's a hex. So I guess we're going to go with that one. Let's see, that's 100 thousandths. So that one's probably not going to make it in, so let's go ahead and add it. But I want to double click. And we're going to look at the insert size, insert name, round 0 degree relief. Let's see if we can find a few more parameters. So D is 5/16. Not seeing seeing anything that's going to let me change that. Oh, there we go. All right, so the IC/diameter, let's bring that down. So 100 thousandths radius, we're still not going to get there with a 1/4 inch, 7/32 at 220. Not quite there yet. Looks like we're going to 3/16. And the thickness at a 1/4 inch doesn't somehow seem right, so 1/8 of an inch. Again, I would like to have this insert in my hand so that I'm actually measuring it. Also the holder, so we can get that that good visual. But if we're going to look at this, probably the numbers. Okay, so it shrank to 3/16 as well, so that should be okay. And if it doesn't bark at me about it, then we'll call it good. And somewhere I saw it to where I probably don't want to keep calling that a 3/8 and program it for a 3/16. So I'm just gonna round to 0.19. All right, so tool number 3 is fine. Feed rate of 2 thousandths per inch or inch per revolution. Plunge rate of 2 thousandths. Spindle speed. And get into that much contact area. I'm still thinking leave it a little bit on the low side, and we can always speed it up. Amount of cut to rough. Let's start off with 30, and amount of cut to finish 10 is fine. Overlap. All right. So if I'm going to use this tool, I went to the trouble of making all these changes. This would be something that I could save back to the library and have it update. If we're only going to use this as a one-off, then I'm just going to hit OK, and it updates the definition. And that'll give me enough that I should be able to find the rest. I did see some center drills in there, so if I can get through it without... So we'll probably go with a 1/4 inch center drill, or spot drill, center drill. There we go. Okay, so I can add that one. Okay, a few more tools in the tool library. All right, so if I add those prior to going through, then I don't have to search through that list. All right, so far we've been kind of going through the list and seeing what we can pick up. So first operation in our recipe book is to run the face, and that's going to be the 80-degree insert. If I'd gone back into that tool and again saved back to the library, then I would pick up our default feed rates. So I'm not sure if that went to the tool, but notice that my comment did pick up from the control definition. So again, a little bit of tinkering and playing with the information. I ought to be able to get this dialed in. And also, I'd have to go back and take a look at my tool settings. If I told it was from the tool, these tool settings just overrode what the control said. So we did keep our max spindle speed of 3,000, so I could build that into the machine. Wouldn't have that off, even if I had a 5,000 or 6,000 RPM spindle. I wouldn't have that off chance of, gee, it can go all the way up to 10,000. All right, so I'm okay with the diameter of 10. We really need to check the machine for what will work on the clearances. Entry amount of 100 thousandths, finish, step overs 10, retract amounts. Really, these are coming in. These are all going to be pretty much standard. So we go ahead and accept. See that it comes in, feeds off, goes a little bit past, and retracts out. All right, so our roughing, we're going to pick up the, and also we are going to switch from wireframe over to solid. So as soon as I come over here and I start selecting, I go, oh, why didn't you select anything? Oh yeah, I need to make sure that I'm selecting for solids. Solid is going to split down through that middle. So that was what I was saying, is that if we shift it, if we transform it up and back a little bit, it's going to see that cross-sectional profile just a little bit different because of that shift. So we want to be careful with it. And now we have the our profile. I'm going to pick up that geometry, and we'll go ahead and hit OK. And let's see, for the